Hey guys, welcome to this lecture. So today we are going to discuss about the zone protection. So we have hosted one website in our Linux server that is in our DMZ zone, right? How can you secure this particular resource from the internet attacks or you can say cyber attacks? Because now this website is available for over internet, so it is but obvious that attackers will try to exploit this service. Okay, so there are multiple techniques to protect this particular resource. In this lecture, we are going to discuss about the zone protection we have from Palo Alto networks. So, zone protection is like a wider protection you apply on a particular interfaces, right? Because a zone can have multiple interfaces, but a interface can belong to a particular zone only, right? So if you go to network, inside network, in network profiles, you have zone protection profile option, right? And if you click on add here, you can, provide protection against flood attacks. If somebody is flooding your network with SYN packets, UDP packets, ICMP packets, right? You can have protection against reconnaissance protection. I mean, if somebody is trying to do TCP port scanning, UDP port scanning, host sweep. So these are the reconnaissance protection you get if somebody is trying to get the information out of your public IPs or outside interfaces. Then it gives option of packet-based attack protection where you can prevent the spoofed IP addresses. You can check for strict IP address. You can drop the fragmented traffic. And if IP options are selected like strict source routing, loose source routing, timestamp, record route, all these things, if these options are selected, I mean the flags are on in the IP header, then you can drop the packets. Then similarly we have TCP drop, so mismatched overlapping TCP segments, split handshake, TCP SYN with data, TCP SYNAC with data, right? So you can simply drop these type of packets. Then ICMP drop, so ICMP ping ID 0, ICMP fragments, ICMP large packet, right? All these things you get the protection against packet based, and then we have IPv6, IPv6 drop, right? Then we have protocol protection. So here you can create the rule whether you need to exclude it or you need to include it, and you can click on add and you can define the protocol and you can define their ether type, right? And those protocols will be protected against the exploits. Okay. Then this is the new protection added later on, Ethernet SGT protection, right? So this is like you can protect your layer 2 information, right? And similarly, you can add your exclude list and you can associate the tags. Okay. So in this lecture, we will see mainly we will see flood protection, reconnaissance protection, right? And packet based and protocol based, we cannot do the recreate for that, so we won't be able to cover this piece. But yeah, flood protection and reconnaissance, we will be able to do it with the help of the Kali Linux. So if you see, we have this Kali Linux to initiate the attacks towards this landscape. So with the help of this firewall, we are trying to mitigate the attacks. Okay. So let's do one thing. Let's create the profile. So let's give it a name. First, we will do the flood protection. Okay. So let's give it a name, flood protection prod profile. Okay. And we will protect it against sin. And inside SYN, you get two options. One is random early drop, another one is SYN cookies. So random early drop is like CPU extensive process, or you can say algorithm. So what happens basically, there are certain triggers which you need to set. That is your alarm rate, activate rate, and maximum. So once the trigger gets activated, it will do the probabilistic drops of the packets incoming flood attack, and once it reaches the maximum threshold, then it is going to drop the entire packet above that threshold, right? So these values you need to set as per your data analysis. You cannot put random number here because it might affect your production environment, right? In case of SYN cookies, so firewall behaves like man in the middle. So firewall is going to respond back to the SYN you're receiving on the interface. It will not forward the request to the destination server, and it will wait for the SYN plus acknowledgement packet. So once TCP three-way handshake is established with the client, then only it is going to forward or relay the connection towards the destination server in our DMZ zone. So this is less CPU extensive, and it is recommended in case of sync floods. Rest, we don't have choice. You can go with random early drops. Okay. So here we will be initiating the sync flood first. So let me just for testing purpose, I'm setting the alarm rate to connections, 10 connections per second. Activate is also 10 per second, and maximum is 40 per second, right? So this is what we are creating right now. And for ICMP, same sort of setting, 10, 10, 40. Then we have UDP, 10, 10, 40. Okay. And then you have other IP. So if you want to do it, you can do this. But we will do the recreate for these two. Then in reconnaissance, we will do port scanning, UDP port scanning. Action will be here you get alert, allow, block, and block IP. So if you allow, so port scanning will be allowed on your outside interface. If you alert, so it will trigger the alert that somebody is doing the port scanning on your outside interface. Block will block the port scanning, and block IP will block that particular IP for a period of time, right? So it is 3600 seconds. I mean, you can configure it. By default, it is 1 hour, right? Because sometimes what happens, somebody is spoofing the IP address, and if you block it for a longer duration, it might be possible that you might end up blocking the legitimate traffic, right? So what we are going to do for port scanning, we will generate the alert and interval 2 seconds, event threshold, let's keep it 10. And I'm just keeping these values low so that we can have the real-time view in the logs. Action will be alert, and here as well, just keep it 10. Okay. And that's it. Packet base, we won't be able to do recreate. So click OK, and just apply it on your zone. So you need to apply this protection on the ingress zone. So our outside zone would be the ingress, that is untrust. So we need to apply it on untrust. So if you open it up, you will see zone protection profile, and you can call this zone protection flood protection prod profile, and enable packet buffer protection. So click OK. Now this is activated. We just need to commit the changes. The logs will be visible inside threat logs, right? So here you will get the logs that what is happening to the traffic, right? And you will be able to see more granular details, and you will see that CPU is also getting high if you are not protecting your resources. So what I'm going to do right now, I'm not committing any change. First I will uh, show you how your session, your data plane CPU gets triggered if you don't have any protection in place, right? So let me just log in into the Kali Linux. Okay, so now we will first do the SYN flood, right? And we are going to use the hping 3. This is the tool to do the flood. Total packet count. So let's say I'm going to send 1 lakh packets, right? And if you want to randomize the source, you can do that, right? So random source, then length, then the target port you are targeting. So we will hit port 80 and target IP. So that is 10.1.1.3, our outside IP, and we will enable this flag flood. So if you do this flooding and if you go to your firewall, here you will see that your sessions will increase drastically. You can see 34 sessions and it will increase, right? So the more number of packets you're going to send, the more, quickly your sessions will burn out and your data plane CPU will also get triggered. So since, the reset timer for TCP connection, I mean, if you go to device, if you go to setup, and if you see session details here, so for TCP SYN, my session is getting discarded if TCP SYN is not, I mean, TCP three-way handshake is not completing. So if we have just received the TCP SYN, so here you will see TCP discard TCP. The TCP session will remains in the memory for 1 hour. Handshake is just for 30 seconds, and TCP initialization when the TCP connection is in init stage, that is we have received the SYN, it is only for 5 seconds. After that, it will be discarded from the session. I mean, session will be freed and the session ID will be returned to the pool, right? So similarly, that's the reason, it is not overshooting. But if you are going to, modify this particular value here, if you make it, 120 or 3600, in that case, you will see that your session count will deplete, right? And slowly you will see that your data plane CPU is also started increasing. I mean, right now I'm just sending very less number of packets, and if I will increase the packet count, this will also increase. So if you go to session browser, you will see that there will be so many browsers, I mean, so many sessions created, right? And we are receiving traffic on this port, right? Source IP will be random. So randomly it will be generating the source IP. So basically we are doing the IP spoofing and we are just hitting, your destination port. And you can see we have the web server access, right? So because your website is reachable over internet, so anyone can do the, anyone can play with it. So you can see the session count, it is increasing. And similarly, if I will increase the packet count, so if I will increase the packet count, then you will see more sessions, right? And sometimes it happens, your data plane CPU also goes high. So now you can see we are able to see more sessions. So the more powerful machine you have to do the attack, right, the more dangerous outcome you can have it on the your victim's infrastructure, right? So this is how the attack we recognize, right? Although if you have not configured any protection profile, so if you go to threat, here you will not get any alert, anything, right? So it is like attack is going on, but nothing is happening. I mean, you're not getting any alerts, any warnings, right? But your resources, they are getting overutilized because of an attack. Okay. So now let's do one thing. Let's try to mitigate this thing. Okay. So if I will go back, let me stop this. Similarly, you can set UTP, I mean UDP attack. So for UDP flood, what you need to do is, let me just give you the example of UDP. So it will remain same, total count random, and here you need to just provide 2 and then your target IP, right? And you need to give instructions that you need to flood, right? So this is, you can see here UDP mode set, right? And now it will do attack on UDP. So if you go to monitor and if you go to traffic, you will see that we are receiving UDP packets now, right? And similarly, if you go to, so it is getting dropped. So because of policy deny as well, we are able to save our resource, this intrazone rule, right? And if because we have created the policy that only Indian traffic will be allowed. So because of that rule, you are able to filter out the traffic. Otherwise, your resources would have depleted very fast. I mean, I'll show you in the security rule. Yesterday we added this India region. So that is the reason half of the traffic is getting dropped because of the security rule, and somehow you are able to save your resources. So, but if there is no such rule available, I mean, if you're not filtering the traffic basis on source region, in that case, your resources might have overshooted, right? So now you can see your data plane CPU, 97%, right? So we have triggered it. And then you will see the production outages. Although the number of session is very less, but your data plane CPU got triggered because it is continuously dropping the packets. I mean, if you see monitor, in traffic, we are continuously dropping your packets. It is receiving huge volume of attack on your outside interface, right? And you are not able to detect it, right? And once it is going to hit 900%, it will uh, go down. And now you can see, zero sessions are there. We are just dropping the traffic, but your users will start facing slowness, production impact will be there. And the moment it is going to hit 100, it will reboot the firewall. Okay, so I'm not going to do that. Let me stop the attack. So now attack has been stopped, and now you will see that this data plane CPU will, become normal, but it will be become normal. I mean, it will take time. So that is the reason a protection is required. Otherwise, any attacker can, overutilize your resources, and they can bring down your firewall itself. And if firewall is down, entire production traffic will go down. Okay. So your entire traffic will go down, right? So let me refresh and see. So now you can see the data plane CPU is going down, right? And slowly it will become 0. And if you go to monitor tab, you will see that you know things are becoming normal. Okay, so let's do one thing now. Let me just commit the changes. So whatever policies we have created, let me apply it, and let's have a look how we are going to get the alerts, how we are going to protect our resources, right? So meanwhile this policy is taking hit. Let me also log it into the CLI of the firewall, just to show you how with the help of CLI you can identify whether DOS protection has been enabled or not. So let me log in into the firewall. Okay, so our rule implementation is almost complete, right? And meanwhile, let me show you this interesting command. So if you run this command, show counter global filter delta yes, right? So it is going to tell you about these counters. What are the counters which are getting modified when you last time ran this command, right? So if you apply this filter delta yes, so next time it is only going to give you the details of the counters which are getting modified. Okay, so how many sessions are getting dropped by the policy, how many packets you have received, all these counters, they are very helpful in doing troubleshooting, because whenever your CPU, your data plane CPU is doing any processing, we have a associated counter for it, and it increase the value, right? So for troubleshooting, it is really very important. Okay, so now if I go here, so this is almost done, right? So we have the protection in place. Let me initiate the attack again. So we'll go with the UDP flood. First, we'll go with the TCP flood. So we have started the attack, right? And let's see, do we have any, you know, so you can see packet dropped, zone protection protocol, TCP SYN, red has been enforced, packet dropped, maximal zone threshold reached, packet drop activating the zone threshold, and now they have identified the, DOS attack. So you can see that it is dropping flow DOS zone. You can see how many packets are getting dropped, right? So this is how packets are getting dropped. And if you go back to the firewall, if you go to monitor, if you go to threat, You must have received the notification as well that you know the attack is going on. And let's just verify. And if you see your resources, now your resources are protected. See, session count is not even increasing, right? Because whatever traffic is getting received, it is getting dropped, right? So this is the beauty. Why, in case of UDP, we were able to shoot up the, this particular data plane CPU? See, when attacker itself is launching the TCP SYN attack or TCP flood attack, if I will listen back to the SYNAC, the attacker's machine itself will go down, right? But in case of UDP, header size is very small. And if I'm generating 1 CR packets, right, I will be able to generate them very fast as compared to TCP packets because UDP protocol is very lightweight, right? So that was the only reason when you initiated the UDP attack, we were able to generate more packets from this particular tool, and it was, hitting the firewall like a real flood. Okay, so let me do that again. So let's start sending UDP flood and see if any data plane CPU gets trigger or session count triggers. So now you can see it will remain like that. So this is how we protect the resources. And if you go back here again, if you just do this, so you will be able to see that packets are getting dropped because of the zone protection, right? So with the help of this protection, we are able to mitigate the attack. Another interesting thing is, you can only mitigate the attacks if it is through the box. If the attack is passing from the box towards the internal infrastructure. If it is coming towards the box itself, then you cannot save that firewall, right? So in our case, attacker is hitting this particular IP address on port 80, which is having a NAT rule to redirect the traffic towards the internal resource. So we are mitigating the attack and we are blocking the entire traffic at firewall level, right? So we are stopping it entering our infrastructure. But let's say this is the management interface of the firewall. And if somebody is attacking the management interface of the firewall, then this attack will become towards the firewall. In that case, you cannot save it with these type of policies. Okay. So towards the firewall, you won't be able to save it. If it is through the box, you can mitigate it. Okay. So if you see now, resources are well in controlled, right? 2%, 5 sessions. We are not overshooting our resources. And if you go to threat logs, we should be able to see the threat logs here. So you can see flood, 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 TCP flood, TCP flood, UDP flood, right? Source destinations, critical, 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 action is dropped. So we are able to get the threat logs. Okay. So now let me stop the attack. Similarly, let's do ICMP flood, right? So hping 3 total count is this random source. Now my protocol number is 1 for ICMP, right? Target IP and flood. So if I do this, now let's have a look. So my data plane CPU is getting shooted, but we have ICMP protection in place. And let me just verify from here. So yeah, it is working. UDP, ICMP, both are activated. So now we are only mitigating ICMP packets. You can see the value, you can see the rate, 10,000 packets per second. This is the rate we are receiving, right? And it is dropping the packets. Now if I will go here, somehow data plane CPU is getting triggered in case of ICMP, which is not good. So we need to check why it is getting triggered. Let me see the policy. If security policies are doing the drop, in that case, your data plane CPU will go high, right? It should be blocked at ingress stage itself. If you go by the packet flow, in ingress stage itself, we have this flow. You can see here, it is getting drop because, all the IPs are allowed and it is getting dropped at policy level. So that is the reason this is overshooting. If you check the policy for port 80, when we were sending traffic towards port 80, only India region was allowed, right? So it was doing the filtering at policy level. So my data plane CPU was, overshooting. In case of UDP, I was able to control it at my ingress stage. So my data plane CPU was not getting triggered. And again, in case of ICMP, it is getting filtered anyhow at policy level, right? I mean, we are getting threat logs as well, and you can see that the zone protection profile is in place. You can see ICMP flood, right? And we are dropping the traffic. But still, by somehow, some of the packets are able to bypass it and they are able to hit the firewall, right? And they are entering the slow path. So if they are going to get into the slow path and security rule is going to do the drop, then your data plane CPU will trigger. So you can see 99%. So let me stop it, otherwise this firewall will crash. So, you know, this is how you need to have your attack mitigation and strategy defined for your infrastructure. And when we talk about zero trust network access, we need to do the threat assessment of your attack landscape. And accordingly, we need to apply the policies and we need to do the micro segmentation of the network, and we can minimize the attack landscape. Okay. So now still it has overshooted the CPU. Okay, let's wait for it. Now we will do the port scanning, right? So we will initiate the port scan attack and we will see how we can identify, you know, what are all the ports which are open. So if I go to Kali Linux again, here you can use Nmap tool, right? And you can do the port scanning, verbose object and IP address 10.1.1.3. So we have started the port scanning. So it will tell us, what are all the ports which are open. And if you go here, if you refresh, so you will get the, details of the port scanning. I mean, you will get the alert, right? And if you go to dashboard, your CPU should cool down. So why CPU is getting flooded? If you go to device and if you see the session timeouts, so for UDP, it is very less. Discard UDP is 60 seconds, and for ICMP, it is 6 seconds. For TCP, 90 seconds. Discard default is 30. TCP three-way 10. TCP initiate 5. Half closed 120. Time wait 15. Right. And normal UDP session is 30 seconds. So this is how your timeouts are playing vital role when you receive any attack. Right. The more value you are going to set here, the more resource utilization you will see, during the attack. So right now we have done the port scanning. So you can see what are the ports which are open. So let me just see. So initializing, scanning, and scanning, but we were not able to see the open ports. Initiating OS detection, Nmap scan report. So MAC address, too many fingerprints, network distance, one hop, and we were not able to get the port details. Reason being that we have the protection in place, right? So, oh, data plane CPU is 100%. So it might reload the firewall. And if I go to monitor, see, that is the reason segregating management plane and this data plane. So if this firewall would have shared resources for management and data, in that case you were not able to open any tabs and all that, because that might have crashed your firewall right away. So that is the reason, since we have dedicated resources available for management and dedicated resources available for data plane, so we are still stable. I mean, we are not running into problems. We can at least do the monitoring and we can restore the services, right? I have stopped the attack, but it is still, it might be possible, few packets are in pipeline here, so they are getting delayed, and because all of a sudden, this remote attacker is sending it towards the gateway, and I told you before that I have a firewall there. So that firewall might have been overloaded, again a VM instance, and now it is releasing the packets again towards the firewall. So that could be the case because we are still receiving the attacks, although I have stopped it from my machine. So you can see how many flood attacks we have received. Similarly, you will get alert for port scanning. So if I go back to dashboard, now resources are under control. And if we will run this command again, packet dropped non-send TCP without session, denied by policy, packet transmitted to control plane. Okay, so now again do the attack. So we are doing the scanning again, and if you go to monitor tab, so we should get an alert for scanning as well. And if you see traffic logs, so you can see 10.1.1252 is our Kali Linux IP address, this machine. So it is just flooding, it is doing the scanning on the random port numbers. You can see it is getting denied because of intrazone policy. So anyhow, our reconnaissance protection is not taking hit if it is getting denied through policy. Otherwise, we would have got the alert here. So need to check why it is not matching. Packet dropped, packet drop zone protection, TCP SYN. It is detecting as a TCP SYN attack, although I'm doing the port scanning. So packet drop maximum zone red activate zone. So it is not able to identify the packets properly. It is considering it as DOS attack only. So that's the reason here you are getting logs for flood, not for port scanning, right? So this is what happening. Okay. And if you see, are we able to receive any information? No, we are not able to identify which port is open. So this is the beauty, right, of the protection policies, and this is how we mitigate. If this would have been like, let me show you. Let's launch attack on Cisco. So if I will do ns lookup for cisco.com, right, or let's say use Ngcloudx because we are using the cloud security feature there. So we have received this particular IP address. So let me just initiate the attack to this IP. So 104.26.4.66. So, we have cloud security enabled there, but port scanning is allowed in my infrastructure, and you can see that these are the ports which are open. Okay, HTTP proxy, HTTPS, alternative HTTPS, HTTP, and you can see uptime and all that details, right? So although this IP doesn't belongs to my main server, the traffic is getting proxied through a firewall and through the WAF protection. So anyhow, we are safe. But you can see with the help of the port scanning, protection, that is the reconnaissance protection we have enabled here. We were able to detect it and we were able to mitigate it. Okay, so this is how we do protection of our resources with the help of zones. In the next lecture, we will see how you can enable the granular control because zone is applied on a broader way, right? I mean, in a zone, you can have multiple interfaces. So it is applied on a broader way. It is highly CPU extensive process. The random early drop itself is very CPU extensive process, and that might be the reason, another reason, your data plane CPU is overshooting. So, to mitigate such problems, we have another option available where we can drop such flood attacks with the help of DOS protection, right? So in the next video, we will see that. So thanks for watching this video. Have a nice day.